Interrelation of coordinates, plots, gradient, slope, speed and rate. In this lecture, we are going to discuss about space and time coordinates and how they are used to develop plots and define the gradient and slopes. We will also be finding which coordinates govern speed and rate. Coordinates. There are three Cartesian coordinates that are used to define the position of an object in 3D space, each of which is termed as axis. There are three space coordinates x, y, and z. These are present at right angle to each other. These coordinates have two directions. They have positive as well as negative values. For example, plus x-axis and minus x-axis, plus y-axis and minus y-axis, plus z-axis and minus z-axis. These coordinates specify the position of a point in 3D space, which is labeled as 3-point numbers. For example, if the position of a point is given as 4, 5, 3, this means that this particular point can be reached by traveling 4 points along x-axis starting from origin, by traveling 5 points along y-axis, and by traveling 3 points along z-axis. These three bidirectional axes are called space coordinate as they tell the position in 3D space. There is a fourth coordinate called time coordinate. This tells the presence of an object at that particular space in time. It does not have negative value. 3 space plus 1 time coordinates specify the position of any object in time and space. Plots. Whenever we get a data set in such a way that the values along one axis are dependent on the values along another axis, the resultant diagram is called a plot. So, the plot is formed between two axes in such a way that one of the axes y is dependent on another x. Conventionally, independent axis is taken as horizontal line and is termed as x-axis. The dependent axis at right angle to the independent one is either y or z coordinate. The plot between two axes such that one is dependent over independent axis is called a 2D plot. Whereas the plot between two dependent and one independent axis will generate a 3D plot. 2D plot generates line while 3D plot generates surface. Let's first understand what the gradient is. Change in value of parameter with respect to the one of the axis or coordinate is called gradient. For example, we are familiar with color gradient used in different graphics. Such patterns are called gradient because intensity of specific color is varying along a straight line drawn through these boxes. In this example, y-axis denotes intensity and x-axis denotes wavelength. So, horizontal axis shows color gradient, steepness of color variation, and vertical axis shows intensity gradient, steepness of color intensity change. Another term we are familiar with is concentration gradient, which is the change in concentration along a straight line, the x-coordinate drawn from the center of its source. Tracking of order is possible along a straight line between the source and receptor. This straight line will be an axis. Diffusion takes place along concentration gradient. For example, spreading of scent of a flower from high concentration to low concentration generates concentration gradient. As value of intensity of fragrance, or more precisely, the concentration of fragrant molecule vary along the axis, it develops gradient. Diffusion is the movement along the concentration gradient. So, the gradient is the change along some parameter, axis or straight line. If this parameter is measurable, is being changed with respect to the independent axis, and its values are plotted along the right angle axis to the dependent one, the gradient will now be termed as slope. So what is the slope? It is the variation in dependent axis value with respect to the independent one. In other words, it is the gradient in 2D plot, like delta y over delta x, or delta z over delta x, or delta x over delta y, or delta z over delta y, delta x over delta z, or delta y over delta z. The value of slope can be fixed or variable. If the value of slope is constant, it will generate a straight line plot. If the value of gradient or slope is variable, then it will generate the curved line, and the slope will be calculated from the tangent to the point on curved line, and its point-to-point value will be different. So, in summary, gradient is the change in the value along some axis, and slope is the change in value of one dependent axis or coordinate with respect to the independent one. Slope is equal to delta y over delta x or delta z over delta x. Therefore, gradient is the change along the axis, and slope is the change along the dependent axis with respect to the independent axis. Therefore, every slope is a gradient, but all gradients are not slope. Speed and rate. When the independent axis is time axis, then the slope of that plot will be termed as speed or rate. Remember that time is unidirectional axis, so it becomes different from other coordinates. Time coordinate is unique. It is unidirectional. This means that it has only positive values that does not have any value in negative direction. Or in other words, it keeps on running in forward or clockwise direction. So it becomes universal independent. Therefore, in most of the studies, the time is plotted as independent axis, not as dependent one. Hence, it will occupy x position, not either y or z position. When x-axis denotes time coordinate, the gradient or slope of resulting plot will stand for speed or rate. Therefore, speed or rate can be defined as a change in value of dependent parameter with respect to time axis. That is, speed or rate is equal to delta y over delta t or delta z over delta t. Speed. When y, the dependent axis, is the measure of position of an object, then its values are denoted as x, and the slope of position x versus t plot is termed as speed, delta x over delta t. When y-axis contains some parameter other than position, then gradient or slope of the plot will be called as rate, delta y over delta t or delta z over delta t, where y or z not equal to distance. So the rate or speed shows the gradient of movement along time coordinate. In summary, x, y, z and t are coordinates. Delta x, delta y, delta z, delta t are gradient. Delta y, delta z versus delta x will yield a plot, and slope is the change in one coordinate with respect to the other. Speed or rate is change in one coordinate with respect to time. Here, if independent coordinate is distance, then its slope will be speed, otherwise it will be called as rate.